Welcome to the channel today. We are still dealing with electrolysis, the calculations involved in electrolysis. We have done the first example, second example, and now this is the third example. The question reads, a current of 2.5 amperes is passed through acidified water for 1.5 minutes, and they required us to calculate the volume of oxygen given off or evolved. Here, the bone of contention is what could be the equation for the reaction. The equation for the reaction. This involves oxygen, of which we know that the dissociation of water involves two things: hydrogen ion and hydroxide ion. Some may say hydrozonium ion and now hydroxide ion. But for this equation, we will use hydrogen ion and hydroxyl ion. But don't forget that the question says the volume of oxygen evolved. Because of that fact, we make deal with hydroxide ion. Look at the equation for the reaction. Hydroxide ion gives you this and this. Let me be putting their physical state. This is aqueous plus 4 electrons. If you balance the equation, let me clean up this one to avoid confusion. If you balance the equation, you know that it should be this: 4 hydrogen, 4 oxygen, 2 oxygen plus 2 oxygen gives you 4 oxygen, molecules of oxygen. And the electrons there is 4. Because of this 4 is affecting the minus here. So we have 4 electrons. So from this equation, remember, this is the reaction at the anode. This will be the anodic reaction. Because negative will always go to what? Positive, as we have learned before. So which means this equation gives off 4 Faradays of electricity. Now let's go back to it. Remember, the importance of writing this equation is to know how many moles of electrons liberated, which the number of moles of electron equals the number of Faradays, or is equivalent to the number of Faradays. That was the essence of writing this whole equation. So if you watch now, Q, which is our quantity of electricity passed, gives you IT. That is the formula for quantity of electricity passed. And from the question, I is the current. I told you earlier that A, amperes, is unit for what? Current. So here now we have 2.5 multiplied by, what is the time? 1.5 minutes. And of which we will convert it to seconds by multiplying by 60. 1.5, that is 1.5 minutes. If you convert it to seconds, you multiply by 60. Let us see what this is going to give us. Q will give us, let's press our calculator to know what it's going to give us. It gives us 225 coulomb. Remember, the unit for Q is coulomb. Now, don't forget the equation here, which means 1 mole of oxygen is liberated. I like writing that in simple sentence. 1 mole of oxygen deposited 4 Faraday of electricity. How is it 4 Faraday? Because 4E is equivalent to 4 Faraday. Deposited 4 Faradays of electricity, out of which 1 oxygen is a gas. 1 mole of every gas at STP equals 22.4 dm3. You should know that very well. So 1 mole of oxygen, which oxygen is a gas, had it been is not a gas, we would have been considering the relative atomic mass of oxygen. But oxygen is a gas. We consider gases in dm3, that is volume. That was why the question asked, that was why the question said, calculate the volume of oxygen involved. The question did not read, calculate the mass. If it is an ordinary element, you consider mass, but this is a gas, we consider volume. And the mole of every gas at STP equals 22.4 dm3. So this thing becomes becomes 22.4 dm cube. This thing becomes 22.4 dm cube, 22.4 dm cube of oxygen deposited 4 times. Remember, 1 Faraday equals 96500 coulomb. That is what one quantity of electricity is, 16500. So now remember they asked us what mole or what volume of oxygen is deposited. We have calculated this column. It then means that X volume or X volume of oxygen will or deposited 22.5 coulomb. I told you in the last video, let coulomb be one side, it's a little proportion, and let the DMP or the mass be one side. So if you watch very well, you do a little cross multiplication, which means that is to say that 22.4 multiplied by 225 all divided by 4 times 96500. Don't forget, this one is coulomb. This one is coulomb. Don't forget. That is the little proportion we have done. Remember, this deposited this X mole or X volume of oxygen deposited this. So now what will be that S? S is simply equals to this. Now let's do the simple calculation. Let's place our calculator to know what it's going to give us. Okay, so we have gotten it from the calculator. This multiplied by this gives us 5040. And when 4 multiplies this one, it will give us this. Now, if you do your division very well, this divided by this will give you this. Don't forget that the first one, the molar gas, 1 mole of the gas is 22.4 dm cube. So it is in dm cube. That is why I'm giving the answer in dm cube. But of which we can still convert it to cm cube. You know how? By multiplying all these things by 1000. But it will not be good that the first one is in dm cube. The final answer should also be in dm cube. But in case you are asked to convert the answer back to cm cube, the best thing you will do is to multiply this thing by 1000. And I guess it should be 13 point something cm cube. If you are multiplying, if you are converting it back to dm cube. So this is a simple mathematics, and of which we will check example 4, then we conclude everything about electrolytic calculations. Thank you.